Pre-statistics. Graphing square root functions, Part 2. Lesson objective. Explain the graphical significance of a, h, and k for the function y equals a times the square root of x minus h plus k. In the previous video, we looked at changing the value of a, where a was larger than 1 and a was in between 0 and 1. So what happens if a is negative? If you recall, our parent function is the square root of x. So if a is negative 1, what does the graph of a times the square root of x look like? We hit graph. Here's our parent function, and here is the new function. So we see that if a is negative, it's really a reflection across the x-axis. If we look at the table of values, we can see the values between y1 and y2 are the same numbers except opposite signs. When this happens, that's a reflection across the x-axis. So here's our parent function. If a is a negative 1, it is a reflection across the x-axis. If the negative is inside the radical, which we're not going to look at in this course, it's a reflection across the y-axis. But for this class, we're only concerned when a is a negative number. This is an increasing function, and when a is negative, this is a decreasing function. As x gets larger, y decreases. So here's our parent function, square root of x. When a is 1/2, it's still an increasing function, but it's not as fast as when a is 1. When a is 2, it's an increasing function, and it's at a faster rate than when a is equal to 1. These three graphs, a's are negative, so they're all decreasing functions. And the larger the negative a value, the faster the function is decreasing. Let's summarize the family of these square root functions. In this form, f of x equals a times the quantity square root of x minus h plus k. A is a vertical stretch, or it could be a compression by a factor of absolute value of a. If a is larger than 1, it's a vertical stretch. If a is in between 0 and 1, it's a compression. If a is negative, then it's a reflection across the x-axis. The value of h affects the horizontal translation. Now, if you recall, translation is a fancy way of saying sliding. So if h is positive, it translates to the right h units. If h is negative, it translates to the left. And if h is negative, then this will become x plus h. K is a vertical translation. It's going to go up or it's going to go down. If k is positive, you translate it up k units, and if k is negative, you translate it down the absolute value of k units. So if k is positive, you go up, k is negative, you go down. If h is negative, which will make this a plus, you go to the left. If k is positive, you go to the right. And a will tell us if it's an increasing or decreasing function. If a is positive, it's an increasing function. If a is negative, it's a decreasing function. So here we have 5 graphs. Here's our parent function. If we look at the red graph, h is 3, k is 0, and a is 1. So comparing the red graph with the parent graph, it's the same graph except for it has been translated 3 units to the right because h is 3. If we look at the light blue graph, it's the same graph as the parent function, except it's been moved 2 units to the left. H is a -2. K is still 0, A is still 1. If we look at the pink graph, K is 5, so it's a translation up 5 units. And if we look at the green graph, K is a -3, so the parent function has been shifted down 3 units. Properties. If we have g of x equals the square root of x minus 2, that means h is positive 2, which means we move the parent function 2 units to the right. If we have the square root of x plus 2, h is -2, we move it 2 places to the left. If we have g of x equals the square root minus 2, we go down 2 units. And if g of x is square root of x plus 2, we translate the parent function up 2 units. If a is positive, it's an increasing function. If a is negative, it's a decreasing function. Here we have a graph where h and k are positive. H tells us how much to move it to the right, and k tells us how much to move it up. And since this is an increasing function, this value of hk is a minimum. For this graph, this is a decreasing function, so that means a is negative, and this hk is a maximum value. Let's do some examples. Example 2. Sketch the graph of f of x equals 4 times the square root of the quantity x plus 2, and then we minus 5. Is f of x an increasing or decreasing function? Is there a maximum or a minimum? Well, because a is 4 and it's a positive number, this is an increasing function. And because it's increasing, it will have a minimum value. The minimum point would be h, k, which would be -2, -5. So if we graph this using our graphing calculator, we see it's an increasing function. Right here is the point hk, and we can use our table and see our hk point is -2, -5. Anything to the left of -2 is undefined. The smallest value of y is -5. Example 3. Sketch the graph of g of x equals -3 times the square root of the quantity x minus 6, and then we add 2. Is g of x an increasing or decreasing function? Is there a maximum or a minimum? In this case, a is a -3, therefore it's a decreasing function, which means there will be a maximum value for the y. H is a positive 6, k is a positive 2. Solution: putting the equation in y1, graphing it, we see that this is a decreasing function, and it looks like the maximum point is here. This is hard to see, so we will use our table, but we know this is occurring at 6, positive 2. So any values to the left of 6 are going to be undefined, and the largest y value is a positive 2. Using our table, we see anything less than 6 is giving us an error, it's undefined. And then the largest y value is the value of k, which is 2. Properties. If a is a large number, then the graph of g of x equals a times the square root of x minus h plus k rises more quickly than the graph of the parent function, square root of x. If a is a positive number near 0, then the graph rises more slowly than the parent function, square root of x. If a is a negative number, then it's a reflection across the x-axis. The value of k is either a minimum or a maximum value for the function. If the function is increasing, where a is greater than 0, then k is a minimum. If the function is decreasing, it means a is negative, then the value of k is a maximum. To sketch the graph of f of x equals a times the square root of x minus h plus k, where a is not equal to 0, number 1, we sketch the graph of y equals a times the square root of x. Number 2, we translate the graph in step 1 to the right h units if h is positive, and to the left absolute value of h units if h is negative. Number 3, we translate the graph sketched in step 2 up by k units if k is positive, and down by the absolute value k units if k is negative. Thanks for watching.